Good morning, students. This session goes with the explanation of what are electric cells, what is an EMF, what is an internal resistance of a cell, and how to determine internal resistance using voltmeter, and related problem we are going to learn. Let us come to the first topic. What are electric cells? You may see clearly in this figure an electric cell consists of two electrodes, positive electrode which is at carbon electrode and negative terminal is a zinc electrode, and sulfuric acid which acts as electrolyte. So what is an electric cell? It is a device which converts the chemical energy of electrolyte into electrical energy. So we come to the another question. Then what is meant by a battery? When several electrical cells are connected together, they form a battery. How does the cell work? When electron moves from the negative terminal to the positive terminal through the circuit, because of the chemical action provided by the electrolyte, there develops a potential difference, and this potential difference gives necessary energy for an electron to move throughout the circuit. Now let us come to the meaning of EMF. EMF is nothing but electromotive force. But it is a misnomer. Students, we have a new keyword in this lesson coming as misnomer. The exact dictionary meaning of misnomer is wrong use of name. Why do we say this EMF is electromotive force is a misnomer? Because it is not a force. It is not a force. Instead, it is the potential difference provided by the battery or the cell for any charge to move throughout the circuit. So we may also explain this EMF as a work done by the battery or cells or a single cell to move the charge throughout the circuit. So it is not a force, it is either a work done to make the charge move, or it is the potential difference provided by the battery or the cell. And so battery, as we have already learnt, several cells connected together or a single cell is a source of EMF. Is a source of EMF. We can measure this EMF with the help of a multimeter by taking a battery. You may just try at your home itself taking a dry cell. You know, you are familiar with the dry cell. Keeping there are two terminals, negative terminal and positive terminal. Taking a wire lead from the dry cell, when it is the leads are given or connected to multimeter, it directly shows what is the EMF of the battery or a cell. Or there is an activity also given. It's a simple activity that clearly shows the working of a cell. You know, a cell consists two electrodes as positive and negative electrodes with an electrolyte. This we can do with the help of a simple activity as it is given in your book. You see there is a lemon. It consists, take a lemon, a zinc rod. Zinc rod is ever kept as negative electrode, and for a zinc rod you may take a nail, and another copper rod, it gives positive potential. When these are kept, and if you take a lead from a multimeter and it shows certain voltage developed inside the lemon, which is the EMF of the lemon. Just the lemon is a source of EMF which gives necessary energy for any charge to move. This is a simple activity we learnt. Now, we come to the internal resistance. Internal resistance is usually denoted by the letter small r. In physics, we just remember internal resistance. Here we denote with the letter small r. So, let us learn what is an internal resistance. Let us take a cell. You know very well, if it is a cell, it consists of electrolyte and two electrodes. One is negative, another one is positive. You know very well that electrons start moving from negative of the battery or the cell. It just moves through the electrolyte and reaches the positive electrode. But when it comes inside the electrolyte, this electrolyte may give certain resistance to the flow of electrons. So, the resistance offered by the consistence of the or constituent of the cell is nothing but the internal resistance. We do not connect any resistance externally, but it is the resistance developed inside the cell itself, which is provided or which is given by the, which is offered by the electrolyte, and this internal resistance is small r. When you just take any ideal battery, it has zero internal resistance. Any ideal battery has zero internal resistance, 0 R. That means if an ideal battery directly shows the EMF of its own. That means terminal voltage of the ideal battery gives the EMF of its own with no change, because any freshly prepared cell has very low internal resistance. But this internal resistance of a cell increases with the aging. If it is used up for long days, then its internal resistance increases. That may affect the terminal voltage of the battery. So, this is about what is internal resistance. So, if we are given any cell newly, we can calculate the amount of internal resistance or the value of internal resistance using the voltmeter. That is our next topic we are going to see. Determination of internal resistance using voltmeter. Here I stress the word using voltmeter. Here in your book, in your textbook, it is also a topic to explain or finding out internal resistance using potentiometer. So, students, be careful, this is determination of internal resistance using voltmeter. As we already discussed, any ideal battery has zero internal resistance, but practically a real battery always have certain value of internal resistance, smaller. So, that makes the real or terminal voltage of the battery, it is always less than the EMF marked on the battery. I am coming to say, you might have seen rice cell, it is written or 1.5 volt, or any other cells like Daniel cell or Reclange cell. The exact EMF will not be obtained when it is used in any circuits. There will be certain fall of value because of the internal resistance of the cell. That is what we are going to measure the internal resistance of a cell, given cell, using voltmeter. Now, let us see the circuit. If it is a cell with an EMF or terminal voltage, which is denoted by the symbol Xi. symbol of EMF. Throughout this lesson, you will be using symbol for EMF as Xi. So, let us take a cell of EMF Xi having an internal resistance small r. It is directly connected to high resistance voltmeter. It is connected to a high resistance voltmeter. Especially we take high resistance voltmeter because it draws feeble current, only weak current to flow through. We can measure the terminal voltage with the help of a voltmeter. Without any external resistance. Without any external resistance, or when a cell is connected to a voltmeter and especially high resistance voltmeter, and this type of circuit is known as open circuit. This open circuit directly gives the terminal voltage or the potential of the given cell. So, terminal voltage will be equal to the EMF of the cell, will be measured with the help of voltmeter. This is the condition where we have not included any external resistance capital R. Now, suppose if we include an external resistance capital R, what happens? Let us see. We are just connecting an external resistance capital R to this circuit. Now, this circuit is not said to be an open circuit, as we have included external resistance. Now, definitely you may see the potential difference across this resistance will be different from the previous value. Let us take the potential difference across the resistance as capital V is equal to capital I into R. We may also observe that this V is less than the Xi. What is Xi? As we learnt previously, that it is the EMF of the cell, that is the terminal voltage of the cell with no external resistance. But when external resistance is included, now the voltage or potential difference across R is less, value is less. Why? What is the reason? Why there is a change in the value from the exact value? It is because of the internal resistance, or the certain voltage has been dropped across this internal resistance. So, the voltage drop across the internal resistance is taken as capital I into small r. So, this value will be the difference, making the difference. This value will be making the difference. So, we can write that V is equal to, from the total value, that is Xi minus capital I R. And so, we get what is capital I into R is equal to Xi minus V. And we have previously seen that V is equal to capital IR, and this is small capital I into small r is equal to Xi minus V. Let us find, using these two equations, as dividing equation 2 by equation 1, which implies IR divided by capital IR, that is equal to Xi minus V by V, gets cancelled. So, R is equal to Xi minus V by V into capital R. This is what is an expression for internal resistance of a cell. And you should remember that if it is a freshly prepared cell, then its internal resistance value is very low. It increases with the aging. So, it is always better to use a freshly prepared cell to avoid such a deviation from the exact value. Now, coming to the power, then what will be the power rating? As the cells we continue to use for a long days, the power rating of the cell will not be exactly same for the because of the continuous usage. So, there will be power loss due to this internal resistance. So, let us find out what is the power loss or the exact power of the cell after many days when it is in use.